Hello there, you all. Today, concept of the day is taking elements in physics. As you all know, most teachers don't particularly teach this concept. I'm going to do continuously 5 or 6 days of continuous video every single day, covering almost all the elements. So today, as day one, we will start with the most basic one, being rod. I am just thinking of very unfunny jokes right now. Anyways, rod. For rod, we are going to consider it as very thin rod, basically of no thickness. I am showing here thickness, but we are generally consider it as something that has almost particularly no thickness. And for this, there is lambda, which is linear density. Which can be written as mass per unit length. Remember this, guys. Mass per unit length is defined as lambda. We are going to do few questions based on it, and also discussing on how to do elements. I'm going to start with a pretty good question, not an easy one. So yeah, let's prepare for that. This question came in 2019 of JEE Mains on gravitation concept. I hope you all are aware of that concept. I'm just trying to teach elements. Just understand how I am doing the question. I will just write the question and the formula. Basically, in that question they mentioned that a straight rod, maybe I should fasten it up. Straight rod of length L from x equal to A to x equal to L plus A. Yeah, that's it. So the gravitational force on a point mass, basically for point mass, force for point mass M, gravitational force. I'm very bad with spelling. If I make some mistakes, please forgive me. Yeah, gravitational force. And also they have modified lambda, linear density. They have written linear density lambda as a plus bx square. I mean, sorry guys, this won't be teaching you that concept well. It will just teach you how to do those particular questions. So bear with me right now. I will teach that concept later. This is the question of the week. Sorry, if the video is a bit late. Yeah. So there is a rod. There is a point mass at x equals 0. I forgot to mention it. At x equal to 0, a point mass M is there. So they are asking the gravitational force between them. So from x equal to A to x equal to A plus L, the length of the rod is A plus L. I think you all understood that. Now force of gravitational force is G m1 m2 by r square. Here r is particularly, to be honest, x. So we are taking an element here. Let's take this. Let's say this is of dx length and the distance is some x. And the gravitational force we want for the entire rod, right? What do you have to do if you want for the entire rod? We have to integrate it. So what is lambda? Lambda as a function of this thing. Lambda is a function of this thing. Lambda is also, I have written it over here, mass per unit length. Here, since we are discussing about a very small distance, very small length, here you can write this mass as some dm. So dm by dx. Yep, we are just going to write that. Here the gravitational force is for this mass, unit mass m, and for this dm. So G of m, and for this particular thing the force is very less, like we are just measuring this. We want the entire thing. Right now we are just taking the small part. So df equal to gm into dm, and for the distance of x square, we are properly making sure the dimensions are same for the formula. Now lambda, what is dm? Lambda into dx by dm. Yep. We got that clear. So if we just substitute that over here, gm of lambda into dx by x square. Now we know that lambda is a plus bx square from the question. So df is equal to gm into a plus b x square into dx by x square. Now we should integrate it to be able to get the answer. I am going to just integrate it, and that is going to be literally just force for this entire system. So we got that force, they are asking that force. Now then gm, I will just take this outside for a bit because we do not need it. So it is a by x square plus b into dx. Now we are going to integrate this. This is a constant gm, so I just took it outside. Now if we integrate it, what are we going to get? Where to where we integrate it? From x equal to a plus l, a to a plus l. I'm sorry for that, congesting the place, sorry about that. Anyways, a to a plus l, a by x square into dx. Just integration, guys, basic integration. A to a plus l into dx, l into dx. So what are we going to get for x square? We are going to get gm a by x power minus 1 minus x from a to a plus l. Wait a second, I'm getting cocoa. And for the mass for that one over there, it is bx from a to a plus l, everyone. From a to a plus l, and now we just substitute gm. Now then we are going to substitute it, a of a plus l minus minus of, wait a second, sorry for that, minus a to a plus l minus of minus a. Yeah, I'm just substituting the values of the integration, nothing complicated. B of a plus l minus a, that's it, there we go, gm. And we are going to get over here just simple arithmetic, nothing complex, minus a of a plus l plus simple arithmetic, guys, bl. And we should get that the force is equal to gm of, if we just take a common, 1 by a minus 1 by a plus l plus bl. This is the gravitational force for that system. And I think you are able to understand how to do these types of question from this explanation. The explanations, I don't think it is very good, but I hope you all get that basic idea. Basically, for these type of questions, we are going to take this small strip. I am going to consider this small strip of length dx, very small length, and of from, if I take it from here, the distance is x. We are going to consider lambda equal to dm by dx. Dm, because at that small distance we have that small mass which is dm, so dm by dx. Why does this is equal to this, you may ask? Basically, per mass per unit length. So the mass and the length, they are in the same ratio such that this is equal to this. I hope you all understood this, and that's it. From this and watching this explanation again, you should be able to do most of the questions. Do try it out. Wish everyone your best, I guess. That's it.